A very good afternoon to all. Today I am going to start a new topic that is the different types of RP processes which is commercially popular and used in the market for developing a different types of the 3D model. Now in this case the first type is stereolithography. Stereolithography. Stereolithography is the best known rapid prototyping system and the technique build a three-dimensional model from the liquid. But in this case, we are using the material that is called the liquid photosensitive polymer, and that solidified when it is exposed by the laser beam. Okay, exposed by the laser beam. The model is built upon the platform, okay, by use of platform, and in this case we are using the photosensitive liquid. A focused UV light, that is ultraviolet light, laser light, traces out the first layer and solidifying the model cross section while leaving the excess areas liquid. In the next step, the elevator take the platform down and the next layer will be formed by the sweeper, and that is equal to the thickness of the layer. Sweeper recoats the solidified layers. Again the same process is repeated and the model has been formed by use of laser light. This process will be repeated till the final model formed. In this case we required a support also, because if support is not provided it will be like the accuracy of the model will be very less. Okay, the support is very important. In this case the support is always required. This is like a schematic or a diagrammatic view of the stereolithography. You have to know how this process is going on and what are the different types of components they are using in case of the stereolithography. In this case, first of all, you have to know the laser light HECD we are using over here. The dancing lenses, the why it is called dancing lenses, because these dancing lenses as well as this mirror is always operated by the system, and that is always depend upon the model required. According to that it will be like directing the least race towards the platform. Okay, towards the platform. Here we are having the sweeper. This sweeper always responsible to flow the one layer of the sensitive photosensitive polymer liquid, and one layer is formed on the platform. This is the platform. Okay, one layer is formed and after that the laser light falls on it. The one layer has been completed. As soon as the another layer will be formed by the sweeper. This is called the elevator, which is responsible to take the platform down and up. Here liquid polymer is there. Okay, and the whole sometime this whole cube is filled with the liquid polymer. Okay, but sometime only this polymer will be filled over here and it is supplied to the sweeper, and the sweeper always form the one layer of the polymer, and every time according to the thickness of the polymer the platform goes down and the new layer is formed. So this is the process, and this will be continue until and unless the whole product is formed. Okay, what are the application range of the stereolithography? The first application you will be find over here, that is called the processing the large variety of photosensitive polymer, including the clear, water resistance and flexible resins. Functional parts for the test you can see over here. Tool for the pre-series production test. We are making different types of tool. We are making the different types of medical model, or manufacturing the different types of medical model. We are always manufacturing the electroforms for the electro discharge machining, that is called the EDM. Form fit functions for the assembly test also. So this is a different types of application and used of the photo stereolithography. Okay, so this is different types of. After that we are having the advantages and disadvantages of the stereolithography. This is also very important. You have to know what are the merits and demerits of the stereolithography. The first merit of the stereolithography: the possibility of the manufacturing parts which are impossible to produce conventionally using the single process. For example, conventional method means like a CNC method, an NC, CNC and DNC, but in case of a stereolithography or the 3D printing or rapid prototyping, we can easily make that model. Continuous unattended operation for the 24 hours. Only one time you have to fit, you have to give the data to the machine, and machine will work for the 24 hours without any interruption. Okay, this is called unattended. High resolution will be, you will get any geometrical shape can be made with the virtually no limitation. Any geometrical shape whichever be required, you can make it. These advantages, many more advantages also there, that is you can learn from the different types of website and different types of rapid prototyping making companies also. Disadvantages, necessity to have a support. This is a very important disadvantage, because if I want to make this kind of a model, okay, this kind of model, so it is always required a support here and here. If you not providing a support, maybe this model having the less accuracy, okay, it will be like tilted one side or another side, it will be tilted like this side or maybe this side, okay, so that will be decreases the accuracy of the model. Hence in this case in this case support structure is must. Without support structure it is not possible, okay. Accuracy is not in the range of the mechanical part manufacturing. This is one of the sometimes we face such a kind of a problem. Restricted area of the application due to the given material properties, because we are using in this case are polymer photosensitive material, and this not having that much strength wherever we required, like this. For example, we are having application where we required like high strength material, but this material is not that much strengthened, okay. So that is a restricted area are there. Labor requirement for the post processing, as you all know, in this case without support structure it is not possible to do the manufacturing of uh, more different types of model. uh, then it is required labor requirement for the post processing and especially cleaning also. So because of this the cost of the product also increases. So this is like a example of this. I'm having a very short video, and this video actually I have downloaded from the YouTube, and it is not used for the commercial purpose, it is only used for the education purpose, so that the student can get understand what is the actual process, okay. So this video actually I am downloaded from the YouTube, so you have to see this video, may and by this video your concept is more clear, means for the student purpose, not for the commercial purpose I am using this video. Just a minute. This is the video for the stereolithography. Just see this video so that your
Stereolithography is a rapid prototyping process used to create parts from 3D CAD data in a matter of hours. SLA is a highly accurate additive manufacturing
sweeper, okay, this is the sweeper.
process and may also be referred to
This is the light which is falls on the photosensitive resins. This is called the laser light.
as rapid prototyping or 3D printing. Models created with this technology are typically used as concept models for form and fit studies or as master patterns for molding techniques. The SLA process begins when CAD data is sliced into thin cross-sections or layers, typically about 6
See, this is a layer by layer formation, as already I have discussed in the last lecture. This is called a layer by layer formation. This is small layer are there, that is called the thickness of the first layer, second layer, third layer and last layer.
thousandths of an inch thick. This data is then transferred to an SLA additive manufacturing system
Machine which is used for forming are different types of model in case of stereolithography.
containing a vat of UV curable photopolymer.
The platform. This actual platform is the sweeper.
The machine begins to build the part one layer at a time. Each layer is constructed from an ultraviolet laser that is directed by X and Y scanning mirrors.
From where the ultraviolet rays are coming from here to here, and
As the laser traces the cross-section on the surface of the resin, the liquid material is hardened on contact. Once a layer is complete, the build platform is indexed down to make room for the next layer. A recoater blade moves across the surface, ensuring a thin coat of fresh liquid resin is evenly spread over the object. The laser continues to trace and form each layer atop the previous layer, building from the bottom up.
okay, this is called the support structure. Okay, this is called the support structure. Without support structure it is not possible to form this model, and this support structure after finishing this model go to the cleaning, and this is one of the disadvantages of this stereolithography.
The completed part is then carefully removed from the liquid and separated from the platform. A chemical bath removes excess resin, and the part is cured in an ultraviolet oven. Any support structures are removed at this time. With numerous hand sanding and professional paint options available through service providers such as Solid Concepts, stereolithography has become an excellent economic choice for rapid appearance models. A wide variety of industries have embraced SLA, including medical, automotive, entertainment, aerospace, and consumer products.
Then this video is available in the YouTube also. You can see from the YouTube also, like a stereolithography technology by MP4. Okay, just I have downloaded from there. Once more time I am telling to that this is not used for the commercial, only for the education purpose I am using over here. Okay, our next type that is called the selective laser sintering. The selective laser sintering is again used for the three-dimensional printing process, but in this case, our selective laser sintering, we are using a powder. Okay, and that powder uh, in the form of like any kind of plastic powder or metal powder we are using over here. Okay, for the sintering purpose. Okay, for the sintering purpose, so you can see over here the process operates the layer by layer principle, same principle as the principle of rapid prototyping. At the beginning of the very thin layer of heat fusible powder is deposited in the working space container. The laser sinters the powder. The sintering process uses the laser to raise the temperature of the powder to point of the fusing without actually melting it. Okay, it is not melted, but it can be fused one layer to the another layer. Okay, if it is melted, the shape will be distorted, but it is not melted. Okay, the temperature of that laser always will be maintained, and it is repeated until the whole like model is formed. The powder is transformed from the powder cartridge. There is a two powder cartridge both the side. You can see the next diagram. Okay, and that is always feeding, and we are having the roller in this case, and that roller like a sweeper will form the one layer, and the platform goes down as per the thickness of that layer. Okay, but in this case no support structure is required. It is overcome the demerits of the or the disadvantages of the stereolithography. Now you can see over here. Okay, here we are using the CO2 laser. Okay, same here also we are using the dancing lenses and dancing mirrors. It is always controlled by the machine. Okay, we are having the two cartridge powder cartridge, and here we are having the powder roller. We are having the platform. Okay, here we have the platform. Okay, in this case the roller will be roll on the platform, and it is always filled by the powder. Here it is will be received powder from this feeder, and once it is rolled, then it form the one layer. From the laser light, it will like a form like a model, which kind of model will be required, and again it will be moved from here to here, and the same model as per the model will be required. Okay, and thus upper layer will be joined to the lower layer, upper layer will be joined to the lower layer, and this kind of things are there. Upper layer from the lower layer. Okay, and this kind of process will be takes place continuously, so that till it is repeated till the final model has been formed. Okay, and every time as per the thickness of the layer it is goes down, it is goes down. Okay, it is not too much difficult once you understood the same process they are formed. Okay, the same principle, each and every method is working. It is not too much difficult. Okay, next we are having the application range. What are the different types of application? The first application like a visual representation model. Okay, the second functional null and tough prototype. we can make the different types of function and a tough prototype in this case also. Okay, we are making the different types of tool for the production test, manufacturing the different types of medical models, as we are making the stereolithography. We are just made it's not that. In this case also we are making the different types of medical purpose model also, and short run and the soft tooling also. With different types of soft tooling, you will be understood in the next to next slide what are the different meaning of the soft tooling. Okay, so this is like a different types of application. What are the advantages? Virtually any material that have a decreased viscosity upon the heating can be potentially used. Okay, these are advantages. Do not require any post curing because there is no support over here required. Okay, no need to create the support structure, which saves the time also and cost also. Advanced software allowing the concurrent sliding of the part geometry files while processing the object. Okay, what are disadvantages? Only 3 disadvantages are there. The first disadvantage are raw appearance. It is one of the disadvantage, but sometime you will find a raw appearance on the part surface due to the hardening of additional powder on the borderline of the object. Necessity to provide the process chamber continuously with the nitrogen to assure the safe. Only for safety purpose we are doing. We have to do this one, rather than this is comes under the disadvantage. Careful handling because we are using the CO2 gases. We are using the CO2 gases. Okay, so for that always you have to go for the proper safety purpose, and careful handling has to be done. Careful handling has to be done because we are using the CO2 toxic gases. Okay, and I am having the 2 more video. This is also I have downloaded from the YouTube. Okay, it is available in the YouTube, but only the educational purpose. I am going to show to the students so that their concept is more clear. Okay, it is not for the commercial purpose. You can see the one by one video so that your concept is more clear. The company name Mass video. Our second video will be clear. Your concept is more and more. Just a minute. Again, I have downloaded this
Selective laser sintering, or SLS, is a rapid prototyping technology that turns 3D CAD data into physical parts in a matter of hours. SLS is an additive manufacturing technology that uses powdered nylon 11, nylon 12, and PEEK materials. Parts produced are lightweight, highly durable, and both heat and chemical resistant, making SLS an excellent choice for producing production parts without the expense of tooling. The SLS process begins by splitting 3D CAD data into thin cross-sections or layers. The data is then transferred to the SLS additive manufacturing equipment. The machine then begins to create the first layer. After a leveling roller spreads a thin layer of powdered material across the powder bed, a CO2 laser traces the cross-section on the material. As the laser scans the surface, material is heated and fused together. Once a single layer is complete, the powder bed is lowered to make room for the next layer. More material is introduced from the powder cartridge and rolled out smooth, while unused material is recycled. The process is repeated, building layer upon layer until the part is complete. As SLS parts are built, they are encompassed by unsintered powder, which provides supplemental strength and eliminates the need for support structures. Complex designs and assemblies, once thought impossible, are now being redesigned with SLS as cost-effective integrated structures. Solid Concepts manufactures parts utilizing nylon with property-enhancing fillers to create rugged SLS parts suitable for a variety of prototype and production applications. Typical uses for SLS include tools and fixtures, fuel tanks, flight-rated components for unmanned aerial vehicles, automotive designs, air ducts, architectural models, and artistic sculptures.
Okay, so this is like a second type of the stereolithography. Today I am going to conclude this session over here. We will see in the next time. Thank you for your great patience. Try to study more and more. This is a very emerging technology and it will be helpful for your future also. Helpful in your future also. Thank you very much.